Okay, in the previous lecture, we have completed the point number 1, that is introduction to communication system. And you have seen the basic concepts and basic parameters comes under mobile communications. That is base station, handoff, forward channel, reverse channel. And we have seen some of the basic parameters out of that is 78 basic parameters. What are the functions of those parameters? And in between, we have completed the cellular concept. What is meant by cell? We have already known that the definition of cell is what? The large geographical area is divided into a smaller area, that is called as a cell or a cellular concept. Why we are using the cellular concept? This cellular concept can be using for mainly the four basic important concepts to improve the performance. That is, one is system capacity, second is quality of service, third is spectral efficiency, and fourth is power management. You have to improve all these parameters. They are going for the cellular concept. Again, I am explaining you this cellular concept. Why? Because this is very, very important. You have to remember this basic concept. Who is going to introduce this cellular concept? That is a Bell Laboratories, BELL Bell. A Bell Laboratories is going to introduce this cellular concept. Why? Because the more and more subscribers goes on, the population goes on increasing as the number of channels are decreases. So the Bell Laboratories are introduce the concept of cellular concept as the number of channels goes on increases. So each and every person has to get the particular channel for the communication purposes. So that is cellular concept. In the cellular concept, we are seeing what are the advantages and what are the problems we are facing in the cellular concept. And one is what is meant by in this cellular concept, you have known what is the mean by cluster. The cluster is nothing but what? A group of cells. Cell 1 A1, cell 2 B1, cell 3 C1. That is one group. A group of cells having a non-overlapping frequency. A group of cells having a non-overlapping frequency, that is called as a cluster. Remember this point. A group of cells having a non-overlapping frequency, that is called as a cluster. And this is cluster is nothing but we are going to defining a shape of particular cell. The shape of particular cell has been declared, that is finalized in the whole world, that is hexagonal. Why they have considered this hexagonal? Because if you consider for different shapes, that is a circle, that is a triangle, that is a square, these shapes are going to have overlapping and there is a gap in between this. If there is no overlapping, if there is no gap in other shapes, but it is going to cover a less area. If it is going to cover a less area, but as compared to the other shapes, the hexagonal cell is going to cover more as compared to the remaining shapes. Consider a circle, consider a triangle, consider a square. Out of this shapes of a particular cell, they are going to cover a less area, less percentage of the area, so that they are going for a hexagonal cell, that is a cluster, that is 7 cells, hexagonal cells. This is what a size of cluster. Yes, we mentioned the number of size of cluster is, you have to remember this. If you want, you can write, that is size of cluster. This is mentioned by n. The cluster is mentioned by n, that is capital N. That is n is equals to the 3 group of cells, that is F1, F2, F3. That is nothing but your 3 group of cells, that is cluster. N is equals to 3, 4, 7, 9, 12 and 21. These are the group of cells which are having the disjoint frequency or non-overlapping frequency is known as a cluster. Group of cells, that is n equals to 3, F1, F2, F3. If n is equals to 4, F1, F2, F3, F4. Same, that is n equals to 7, 1 to 7. This is what? A group of cell. F1 is one cell, F2 is other cell, and F3 is third cell. A group of cell having a disjoint frequency or the non-overlap frequency, that is called as a cluster. And the cluster, they have asked you the question, if the size of cluster is small or the size of cluster is large, what happens in this? If the cluster size is small, that is n is equals to 3. If you consider the size of cluster size is 3. If you consider the cluster size is 21, what it happens? If there is a smaller the cluster, if the size of the cluster is small, the capacity increases, but interference would be more. Capacity, the quality of service will be increases, but there is a more number of interference will be occur if the cluster size is less. If the cluster size is more, the capacity or the quality of service will be decreases and interference will be less as compared to small cluster or a regular. That is what they are going to consider the cluster size minimum as 7. That is a cluster size is less. That is, if you divide the cell into the number of cells, that is a small cells, that is you are going to increase the number of quality of service. So they are going to consider a small cluster size. Okay. If you define the shape of particular cell, what is required? If you define the shape of a cell, if a shape of cell is circular, if a shape of cell is triangular, if a shape of cell is square or the hexagonal, what is required? It must be geometrical in shape. Geometrical is nothing but what? Circular, triangular, square or a rectangle, anyone. Okay. The second point is it should have a more and more circle. It should represent a circle. A particular shape has to represent a circle. The third main important point is what? When we join the shapes of this cell, there should not be any overlapping or there should not be any gap. See here, what are you are seeing the circle? In this circle, there should be overlapping is seeing. You are seeing the overlapping in the particular circle and there is a gap in between the two circles. Overlapping leads to the interference of a signal. Overlapping is nothing but what? It is going to provide a interference. The gap results in the loss of coverage. Gap is nothing but it is not going to cover a particular area. So that is a percentage of this coverage is very less. And if you consider the second shape, that is a triangle. That is a triangle. There is no overlapping. There is no overlapping, but there is no gap. In this triangle, there is no overlapping, but there is no gap. But it is going to cover a less percentage of the area, that is 17.77%. It is going to cover a 17.77% of a area. If you go for a next, that is a square. In this square, there is no overlapping, there is no gap. But it is going to cover a less area, that is 63.7% of the area. 63.7% of the area. If you move towards the hexagonal, if you go on for a hexagonal has a represent a circle. All this geometrical shapes is going to represent circle, and this hexagonal is also represent a circle, but hexagonal is going to cover more and more area, that is 83% of the area. 83%. So the word has finalized. We have to move towards a shape of a cell is hexagonal, not a circle, not a triangle, not a square. So they have finalized the shape of a cell is hexagonal. Remember this. What are the types of cells? What are the types of cellular concept of the what are the types of cells? One is macro cell, micro cell, pico cell, selective cell, and umbrella cell. These are the 5 cells we are using the types of cells. One is macro, second is micro, third is pico, fourth is selective, and last is umbrella. Where actually we are using the cells? Where actually you are using the cells? The macro cell, the first one. The macro cell is mainly used the remote areas where the population is less. Where the population is less, we are going to use a suburban areas. Suburban areas, that is to cover a minimum of 10 kilometers. It has to cover a minimum of 10 kilometers. We are using a particular cell as a macro cell. Micro cell is again a little bit small cell, that is micro cell. We are using a larger populated area or the densely populated areas. It is going to cover more than 10 kilometers, around 10 kilometers. That is, we are using microcell. And the third is picocell. The picocells where you are using, we are we are living inside the buildings. Inside the buildings, number of flats we are seeing at the urban areas. In those, at that time, if you want to get any network inside that building, we can use a picocell. We can use a picocell. These cells are using in the buildings and the tunnels where we are using, or the we are moving in the number of highways, we are seeing the number of tunnels, that is for 10-kilometer tunnel, 20-kilometer tunnels. In those tunnels, we are getting the network. For that network, we use the particular cell as the picocell. The picocell we are using. Selective cells. Selective cells are nothing but we are using the directional antenna for this selective cell. So the directional antenna is nothing but the antenna should be mounted in a direction. There are degrees. That is for a 30 degree, for a 60 degree, for a 90 degree, for a 120 degree, or a 180 or 360 degrees. What these selective cells are going to do this? The selective cells is going to fill the gaps and the holes in the coverage. Fill the gap is nothing but what? Where it is filling, see this. There is a circle, there is a overlapping is there, and one more circle, there is a gap in between this. This gap is going to fulfilled by this selective cells. The gap has to be covered by this selective cells. And umbrella cells. Umbrella cells is nothing but what? It is like an umbrella cell. That is, whenever you are moving for a longer distance communication, you are crossing a number of towers, a number of antennas, you are getting the number of channels. Then if you are in a call, your call will be handover for one antenna to the other, one tower to the other tower. That is, we are crossing number of base stations. We are crossing number of base transceiver station, that is BSC. Okay, transceiver station, that is BTS or BSC, base transceiver stations, base station controllers. At that time, we are using this umbrella cells. So this is what a concept of the second point, that is your cellular concept. The cellular concept is nothing but what? A larger geographical area is divided into a smaller cell, that is called as a cellular concept. What is meant by cluster? The important point is cluster is what? A group of cell having a non-overlapping frequency or the disjoint frequency, that is called as a cluster. The cluster has been assigned by a symbol, that is a word, that is N, capital N. Capital N is assigned by the cluster. That is a cluster size should be 3, 4, 7, 9, 12 and 21. Okay. If you want to use a smaller cluster, capacity increases, interference is more. If you want to use for a larger cluster, that is a capacity less, interference will be little bit less. And we have finalized, the word has finalized the shape of a cell is, that is hexagonal. Why? Because it is going to cover a more and more area. And the types of cells, that is microcell, macrocell, picocell, selective cell and umbrella cell. This is the point number 2. And the point number 3, which is related to your cellular concept, frequency reuse. We are using the same frequency of a particular cell in the other cell, that is with the somewhat distances, that is a neighboring cell, okay, with some distances. The frequency reuse concept is nothing but the frequency used in one cell, the same frequency can be used in one more cell with a sufficient distance is called as a frequency reuse. What is the definition of frequency reuse? The frequency used in one cell can be reused in the other cell with a sufficient distance is called as a frequency reuse. What are the benefits of this frequency reuse? It allows communication with the cells in a given frequency. Whatever the frequency you are using in one cell, that is A1, and the same frequency can be used in A1 of a cell with a sufficient distance. Okay, whatever the power we are used, we can save that power. That is also one of the benefit in this. For a one cell, we are using the 10 to 50 frequencies per cell. So whatever the benefits of this, we can use one frequency of a cell can be used in the other frequency in other cell with the sufficient distances. If you want to calculate for this, whatever, how to calculate this frequency use, that is to be calculated by using that is k divided by n. The k divided by n, that is a total number of frequency that is assigned by k. Total number of frequencies that is assigned by k. What is n? The cluster size. That is cluster size is n. In this, he has mentioned one of the numerical that is in advanced mobile phone service, that is AMPS. Advanced mobile phone service, the K, that is total number of frequencies are 395. Total number of frequencies available in a particular cell. Okay, that is 395 and the cluster is 7. In a 7, one group of cells having a disjoint frequencies, that is n, that is 7. The frequency per cell we have to calculate. The frequency per cell is nothing but A1. A1 is having how many frequencies? A2 is, B1 is having how many frequencies? C1 is having how many frequencies? D1, E1 and F1, like this. That is to be divided by 7. 395 divided by 7, we get a individual frequency band for a particular cell. Individual frequency for a particular cell. Okay. If you want to give a particular example for this frequency reuse, that is to be 3 into 3 frequency reuse. 3 into 3 frequency reuse or 4 into 3 frequency reuse. 3 group of cells into 3 cells. 3 is total group of cells are 3 clusters. Okay. To write this, A1, A2, A3, that is 1, B1, B2, B3, that is 2, C1, C2, C3, that is 3. Okay, that is 3 into 3. Group of cells A1, A2, A3, 3. 3. And the cluster is again 3. That is A1, A2, A3, B1, B2, B3, C1, C2, C3. That is 3 into 3 frequency reuse. One more example, that is 4 into 3 frequency reuse. 4 into 3. The group of cells are 4, but number of cells are 3. The cluster is 4. Cluster is 4. A group of cells, that is particular cells are only 3. That is how it is. 4, A1, A2, A3, B1, B2, B3, C1, C2, C3, D1, D2, D3, D1, D2, D3. That is 4. Okay, group of cells only 3, that is A1, A2, A3. In like this, you have to give the particular examples for frequency reuse. Okay, why this is using frequency reuse? It is going to save the bandwidth. How it is going to save the bandwidth of this? Why? Because the whatever the frequency used in one cell, the same frequency can be reused in other cell. So whatever the bandwidth can be used in one cell, the same bandwidth can be utilized for other cell. So it is going to save the bandwidth. The second is each base station allocated a set of channels. It is a must. One cell, an individual cell having its own base station. An individual cell is having its own base station. Yeah, the own base station is having its own channels. The own base station is having its own channels. That is, whatever the each base station is having a own channels. That is, each base station allocated a set of channels. The channels of one cells are different in channels of neighboring cells. I already told you, whatever the channels used in one cell, that is A1, the different channels can be used in B1. The different channels can be used in A2. A1, A2, A3, this is the 3 cells. A1, A2, A3, these are the 3 cells. So A1 is a somewhat channels. B1 is a different channels compared to the A1, and C1, A3 is having the different channels compared to A1 and A2. Getting the point? The number of the set of channels using for different cells are different. Okay. And next, each cell has its own base station. Already told you, each cell having its own base station. And it is going to process a proper coverage, better performance. It is going to give that. If you want to use for a number of cluster size, that is n is equals to 1. If you use for a frequency use factor, that is 1 by cell. Every cell has having one cell, that is 1 by 7. So if you want to calculate the total channels, if you want to calculate the total channels present in a particular cell, total channels present in a particular cells, that is to be k into n, k into n, that is the number of frequencies into number of clusters. Okay, set as each cell and a cluster size. If you want to calculate the capacity of particular cell, to improve the particular cell, that is C is equals to K into M into N. Number of times N is duplicated. That is M is nothing but what? How many times you are going to use a particular cluster. M stands for how many times you are going to repeat a particular cluster. How many times you are going to repeat a particular cluster, that is to be assigned by M. To improve the capacity of a system, that is to be A is equals to K into M into N. If you want to calculate the total number of channels, S is equals to K into N. That is to be calculated by frequency reuse factor. Next, already told you who is going to allocate this frequency. That is one of the organization, that is International Telecommunication Union. This International Telecommunication Union is going to assign a particular frequency band to the particular country. The whole world is divided into 3 regions, that is region 1, region 2 and region 3. Different countries will be mentioned in this region 1, region 2 and region 3. There is one of the example we are using this, how to use this frequency reuse. If a cable operator having 12 into 10 raised to 6 bandwidth and the radio frequency size is 200 into 10 raised to 3. If you want to calculate for a particular channels present in a particular cell, that is to be the operating frequency, that is bandwidth divided by frequency you have to do, so that you will get a particular channels present in a particular cell. The total channels present in a cell is 60. The total channels present in a cell is 60. Okay, he has mentioned that is the number of cluster is n. N is equals to 7. You have to draw a particular hexagonal cell as n is equals to 7. Okay, how many channels you got? That is 60 for n is equals to 7 cells. For 7 cells, the total number of channels are 60. If you want to calculate for each cell, that is individual cell, that is 60 divided by 7 you can do. That is 60 divided by 7, you will get a particular individual cell having a channel is 8 channels per cell. So 8 channels allocated for A1, 8 channels are allocated for A2, 8 channels are allocated for A3, 8 channels are allocated for A4, 8 channels are allocated for A5, 8 channels are allocated for A6 and 8 channels are allocated for A7. The group of cells having a disjoint frequency n is equals to 7. 7 is there, you have to draw 7 hexagonal cells. You have to draw the 7 hexagonal cells. In that you are going to use a particular individual channels, that is to be divided by 7, so that you can calculate it. An individual cell is having how many channels. That is to be how to calculate frequency to use particular channels in this. Similarly for this, if you want to calculate the cluster size, if you want to calculate the size of cluster, how we are going to calculate the size of cluster? The symbol is the capital N. The symbol is capital N. The N is equals to in bracket I comma J. If consider that is I is equals to 1 and J is equals to 2. I is equals to 1 and J is equals to 2. If you want to calculate for a particular cluster size, that is N, the formula is I square plus Ij plus J square. Write down this formula. For calculating the cluster size. For calculating the cluster size or size of cluster, the formula is I square plus ij plus j square. I square plus ij plus j square. He has already mentioned the data, that is I is equals to 1 and j is equals to 2. Just substitute those values in this formula, that is I square is 1, ij is 2 and j square becomes 4. So size, you can immediately get the size of cluster, that is n is equals to 7. Similarly, if you want to apply for this, I is equals to 1 or j is equals to 1, you will get the cluster size as 3. Cluster size as 3. Same way, you have to calculate the size of a cluster. Okay. If you want to improve the capacity of a system, you have to use this formula, that is m into k into n. M is nothing but what? A multiple clusters. Cluster is nothing but what? A group of cells having a disjoint frequency or the non-overlapping frequency, that is called as a cluster. Okay. If you increase, if you want to repeat the number of clusters, the capacity goes on increases. How the capacity will increases? Just by increasing the number of cells or just by increasing the number of clusters. Not like that. If you repeat the particular frequency used in one cell, the same frequency can be used in other cell with the sufficient distance, that is to be increases. Just increase the number of cells or not, that is not like that. For improving the capacity of cluster, you have to increase or repeat the number of clusters. That is what we are using frequency reduce. These 2 points are very, very important. One is cellular concept, one is frequency reuse. I hope you understood. Next point for this unit is channel assignment strategies. Channel assignment strategies. The word itself will tell you the answer. Assigning the channels with the different strategies. There are 2 strategies we are using in this. And why we are using this channel assignment strategy? Because you have to minimize the interference. We have to reduce the disturbances and to increase the capacity, to increase the performance or to increase the efficiency. We are using this channel assignment strategies. And this channel assignment strategies is divided or it is categorized into 2 types. One is fixed channel assignment strategy, one is dynamic channel assignment strategy. One is fixed channel assignment strategy, second is dynamic channel assignment strategies. Fixed, what is the meaning of this? Fixed number of channels. Dynamic is variable. Dynamic is variable. Fixed is fixed. Okay. Fixed channel assignment is nothing but the whatever the channel assigning are fixed. Dynamic are variable, that is unstable. In this fixed channel assignment, they are using in the previous years, that is 1956. They are going to create a problem for assigning the channels. At that time, whatever the channels are there, those channels are divided for a particular cell. Those channels are divided. Okay, that is channels are divided in a sets of cells. Fixed channel assignment strategy meaning is what? Whatever the channels are assigned, they are permanent. They are fixed. They are permanent to the particular area or permanent to the each cell or permanent to the particular user. That is, a set of channels are is permanently allocated to each cell in a network. A particular network is having a particular channels, and a many number of channels are allocated to the particular network. These many channels, the 12 channels are allocated to the particular network, and 18 channels are allocated to the particular network. 6 channels are allocated to the particular network. Those channels are fixed. Some set of channels must be assigned to the cell separated by certain distance to reduce the co-channel interference. If you want to reduce a particular interference, that is disturbance in the signal, with the you have to maintain a sufficient distance to reduce the co-channel interference. What happens in fixed channel assignment? If you want to make a call, if you want to make a call, if the channel is available, fixed, I am explaining for a fixed channel. If channel is available in that cell, then and then only the call will be connected. Previously, in the 1956 or 1970s, if the channel is available in the particular cell, your call will be connected. If channel is not available, you have to wait for an minute or 15 minutes, 30 minutes to get a one channel. So any call attempt has to be made. If unused channels has available, then and then only your call will be connected, or your call will be disconnected because the channel is not available in a particular cell. The channels available in particular cells are all are allocated already. If any channel is free, that channel will be allocated to you. If it is not free, the channels, all channels are allocated, will not be able to make a call that time. What they are using, the one more, they have to borrow the particular channel from the adjacent cell. If the cell is available, if the channel is available in A2 cell, A1 cell is having 6, A2 cell is having 6, and A3 cell is having 6 channels. For example, A1 cell 6 channels are all allocated, are all busy. In A2 cell, 5 are allocated, one channel is free. One channel is free. So that channel has to be taken at A1 cell. That free channel has to be given to the A1 cell till the end of the call. Once the call has been over, that channel has to be returned back to the A2 cell. That once the call has been over, that channel has to be returned back to the A2 cell. This process is called as a borrowing. उधारी लेते हैं ना, वैसे it has to be using a borrowing cell. This borrowing process has to be used in fixed channel assignment strategies. If all the channels are allocated in a particular cell, if any person or any user wants to make a call, they has to borrow the cell from an adjacent cell. Once the call has been over, that channel has to be returned back to the particular cell. That is what the concept in this. To be available for borrowing channels must not interfere with the existing cells. Whenever you are taken from a channel from the other cell, it has to be taken care that the MSC has to be taken care that there should not be any interference, there should not be any overlapping between the two signals. That has to be taken care by mobile switching center, that is MSC. That has to be taken care by mobile switching center. This is what a fixed channel assignment strategy. Fixed channel is nothing but, so whatever the channels allocated are fixed. They are permanently allocated channels. That is not a variable. If a channel is available, the user can make a call. If the channel is not available, user cannot make a call. Okay. The one more process you can do is, you can borrow the channels from the other cell if there are free number of cells are available in adjacent cell. That is what we are using in fixed channel assignment strategy. The second type of this is dynamic channel assignment strategy. Dynamic channel is nothing but what? Variable. unstable, it is not stable. In fixed, number of channels are permanent. In fixed, number of channels are permanent, but in this, the channels are not permanent. Why? Because we are moved towards a cellular concept. We have moved towards the cellular concept. The number of channels will be increases. Whatever the channels are going to allocated for a particular user, they are dynamic, differential. अभी आप एक कॉल करेंगे, द चैनल इज डिफरेंट. अब दूसरा कॉल करेंगे, दैट चैनल इज डिफरेंट. So for multiple callings, the channels are different. For multiple callings, the same channel will not be allocated for you. For multiple callings, multiple channels. That is what we are using going for dynamic channel allocation. And when they are going to, at what time they are going to use this? Whenever you want to make a call, that request has to be sent first to the base station, that is BTS, base transceiver station. Next, that is BS, the base transceiver station send a request to the BSC, that is base station controller. Next, base station controller has sent request to the MSC, that is mobile switching center. This mobile switching center has to confirm all the given information is authenticated or not, everything. Once it is authenticated, once the user is authenticated, the channel will be allocated. So all the process has to be done in dynamic. First, the request goes to base station, that is base transceiver station, and that BTS will send a request to the base station controller, that is BSC, and BSC will send request to the MSC, that is mobile switching center, and then only your channel will be allocated. At that time, that is to be taken observing by the MSC, that is mobile switching center has to observe a particular call. There is no disturbance in between the call. There is no deactivity, that is disconnectivity in between the calls. That has to be taken care by this MSC. That has to be happens in dynamic channel allocation. And similarly for this dynamic channel allocation, we are using different number of controllers. Okay, for a new call, a free channel from the central pool is selected based on either a core channel distance or a signal strength or a signal to noise ratio. So to calculate for this dynamic channel is nothing but what? You have to use a particular concept for this dynamic channel. If more number of channels, more number of users. The point is what? If a multiple number of calls, the multiple number of channels. How the users are goes on increases and channels are also goes on increases. This type of method has to be taken place in dynamic channel assignment strategies. Today we have seen one is cellular concept we have seen. A second point we have seen is frequency reuse. We have seen this frequency reuse definition. At least you have to remember the frequency reuse, the definition. What is a cluster? What is a shape of cell? At least you have to remember that one. Okay, frequency reuse, the frequency of one cell can be reused in other cell with a sufficient distance. Okay, cluster, a group of cells having a disjoint frequency or the non-overlapping frequency, that is called as frequency reuse. Okay, what is the shape of cell? That is hexagonal. Shape of cell is hexagonal. That is cellular concept. Frequency reuse, same thing we are going to calculate for cluster. The formula is I square plus Ig plus J square for calculating the cluster. And for similarly for there are different types of channels we are using. Channel assignment strategies. One is fixed, one is dynamic. Fixed is nothing but the channels allocated are permanent. The channels allocated are permanent. Okay. If you want to take any channels, you have to borrow from the other end of other adjacent cell. Dynamic channel assignment. Dynamic is nothing but variable. That is, the channel is not fixed. You can take the number of channels from the number of cells also. Okay, that is freely available. That is, we are using channel assignment strategies. The next point is handoff. Tomorrow I will ask you the same questions for anyone. Remember this handoff. Already you have seen this handoff. What is handoff? whenever the user is moving from one cell to the other cell, that is moving, for example, we are moving on the highways, you are sitting in the bus, or you are driving a car, you are sitting in the train, you are crossing many number of base stations, you are crossing the many number of base stations, and that base station you are allocating the different number of channels, you are going to hand over, you are going to shift many number of channels. That is what handoff. Okay, that is what, when a user moves from one cell to the other, to keep the communication between the user pair, the user channel has to be shifted from one base station to another without interrupting the call. Means, if you are in a communication, you are speaking with the other person, okay, you are crossing a number of base stations, that is number of BTS, base transceiver stations. At that time, you are going to have a different channels, you are going to get a different channels, you are not knowing that internally, you are going to allocate different channels, but your call will not be disconnected. That has to be taken care by MSC. That has to be taken care by MSC, that is mobile switching center. When a mobile station moves into the other cell, while the conversation is still in progress, the MSC automatically transfer the call to the new FDD channel, that's a frequency division duplexing. The frequency division duplexing channel without disturbing the conversation, this process is called as handoff. Means what? All this process has to be taken care. All this process has to be monitored by only one head, that is mobile switching center. This is handoff. This handoff operation has to be identifying a new base station has to be taken place. You are crossing the number of new BTSs that is to be identified. Reallocating the voice and control channels to the new base stations whenever you are moving, that is to be allocated, and that has to be done by the mobile switching center. This is one of the diagram of handoff. Two base stations, there is a one vehicle is there, two base stations. At the end of this one base station, at the one end of the cell 1 and the cell 2, two cells are there, A and B, at the end edge of the cell. At the edge of the cell, there is a handover. Very small time, in a little bit fraction of seconds, the handoff starts and handoff ends. We don't know when it starts, when it ends, but there is a handoff in every situation, in every communication. So that has to be taken care by this handoff process. Okay, the definition you have to remember, and the remaining next handoff process we'll see in the next lecture. We'll stop here. Prepare for question answer session for 5 to 10 minutes for next lecture. Okay, we'll stop here today. Your attendance, please.